So what I'm going to show you is how to do a basic fit using pytc. And so what we're going to do is go and first load in an experiment by going to File, Add Experiment. And now what we're going to do is load in the result of an ITC experiment. So what we're assuming you've already done is gone and done an experiment and then integrated the heats in that experiment using origin or nitpick, and then saved those heats out as either a DH file for origin or as an exported results for nitpick. We can then select the file that we're going to load in. In this case, I'm loading this file called HEPES01, and what that is a calcium binding to EDTA experiment in the HEPES buffer. We can select a label for that experiment. That can be any identifier that we want that helps us keep track of the experiment during the fit. We're going to select the model we're going to use for the fit. This is either a single site model, which is the default, or a variety of other models shown here under the select model dropdown. The shot start is the first shot we're going to exclude in the experiment. We're going to leave that as 1 for the moment. The uncertainty is our estimated uncertainty in each heat. Now, if you do your integration using nitpick, you'll get this for free. This will actually be part of that output file. For origin, we just kind of have to guess what it is. One thing I like to do is just make fairly aggressive guesses. So what I'm basically saying here is my fit uncertainty is 1 cal per mole per shot, which is actually a fairly big uncertainty. But we'll see how that propagates into our fit parameter uncertainty. So once we're happy with this, we can hit OK, load in that experiment here, and you'll notice here are all of our individual data points as a function of molar ratio. These are our heats per shot. With our data point and our uncertainties shown as error bars. The line you're seeing is our initial guesses for our fit, which are pretty terrible, but we'll be able to fix that with our fitter. Okay, so the next thing we're going to do is go over and change some of our fit parameters themselves. So if you click on the triple bar icon next to HEPES01, we can load up its various fit parameters. So we can do things like set the guess for our binding constant here. So let's change that value to 10 to the 5th. What we see is the curve gets shallower there in the back. We change that to 10 to the 7th, it gets steeper. So this is how we can play with our fit parameter guesses to try to get better fits. You'll notice we also have options like fixing that parameter or setting upper and lower bounds on that parameter during the fit. The thing we're going to do though here is look at this first point. So that's an messed up point, as often happens in ITC experiments. The first point is invalid due to mixing, so we're going to get rid of that point in this following way. We'll just set that shot start to 2. Now we've removed that from the fit. Okay, now we're going to do the fit itself, so you can go down here to the big button at the bottom and say do fit, and it will perform the fit. So that's what we have here. We've got our fit through our points shown at the sort of main graph. Below it are our fit residuals. So this is the difference between our fit and our input model. This should be random and sort of randomly scattered around this point across the titration. In this top right corner here, what we have coming out are the various fit statistics, ranging from things like the R squared for our fit, as well as things like the number of parameters and the number of observations. And if you didn't notice before, this also just is a general logging tool that will spit out things as we manipulate the fitting environment. And last but not least, we have down here, we have the output of our fit. So these are the different fit parameters. So for example, here we have our binding constant, where we backed out a value of 3.7 times 10 to the 7th for our binding constant, as well as our estimated standard deviation and confidence intervals on that fit, 95% confidence intervals. The last cool thing that comes out of this fit in pytc is this thing called a corner plot. So if we click over here, we can see that. And what a corner plot shows is our uncertainty in our fit parameters, in this case our binding constant uncertainty here, and our binding enthalpy uncertainty here as a distribution, but then also the covariance between them. So this basically shows this three-dimensional histogram here. We're looking down on it as a topo map. If these parameters were completely uncorrelated, this would be a circle, but as we can see, they're actually correlated with one another, so that as we increase, if we had a slightly higher estimate of our binding constant, we would have a lower magnitude of our enthalpy and vice versa. And in this case, it's a pretty small correlation, but in some fits that can be pretty profound, so it's an important thing to know how to access. Finally, we can export our results. We go up to File, Export Results. We can then choose a directory where we're going to write this out. So I'm going to give this a directory name called results, and I'm going to save that. It's going to put out all of this fit information into a single directory. I can then load up that directory here. And if we look in results, you'll notice we now have PDFs corresponding to our two fits, as well as our fit parameters as a CSV file, which you can then load up in your favorite spreadsheet program. So here we've got our fit values in the spreadsheet program, as well as this is the log file for the session that was spewed out of the top there. So now you know how to do a basic fit using pytc.